Today we're going to take a look at section 9.2, which is polar equations and their graphs. So first thing we're going to do is we're going to do a little bit of review from section 9.1. All right, so the first one we are going to convert to rectangular coordinates. So remember that this is r and this is theta. Okay, so if I went to negative 330 degrees, if I add 360 to that, that's the same as 30 degrees. So if I go around backwards, 330 degrees, I'm at 30 degrees in the positive. Okay, but because that ray is, or that r value is negative, we're going to go on the opposite ray 2 circles, and our point would be down here in quadrant 3. All right, so remember our two formulas for going from polar to rectangular are x equals r cosine theta, and then y equals r sine theta. Okay, and those were from that last section. So again, we're just going to use the points -2 for r. So it's -2 times cosine of negative 330. And then y is going to be equal to -2 times the sine of negative 330. So at 30 degrees, our ordered pair is √3/2, 1/2. So again, we want exact values since this is a unit circle problem. So our x value is going to be -2 times the cosine. Remember, the cosine is the x value. So that's going to be -2 times √3/2. So that gives us -√3 for x. And if we go to the y value, that's -2 times sine of negative 330, which is 1/2, so that gives me a y value of -1. Okay, it's always good to check, does that make sense? If I go back -√3, which is almost 2, and then down 1, that would get me to that point there. So I know I am at least in the right quadrant with that one, so it's kind of a little check there. And there's our ordered pair. And again, this ordered pair is in rectangular, so this is my x and this is my y value. All right, so now we're going to do the same thing, but this one is polar. We're going to convert to polar. So this is in rectangular, so that's x comma y. So again, our point we know is at -2 and then +2, so it's in quadrant 2 here. All right, so let's go ahead and find r. So we know that r squared is equal to x squared plus y squared. So I know r squared is going to be the same as -2 squared plus 2 squared. So that's 4 plus 4, or that's 8 for r squared. If I root both sides, that gives me the square root of 8, but remember we get plus or minus. So r is going to be plus or minus, and that breaks down into √4 and √2. So plus or minus 2√2, there's my r values. So remember when we did these, we always found two polar coordinates. So one of them is going to have a positive r value of 2√2. And the other is going to have a negative r value of -2√2. To find the angle, remember we use tangent of theta is equal to y over x. So in order to find theta, we're looking for a tangent value that is the y value, which is +2 over -2. So that means we're looking for a tangent value of -1. That is a unit circle value, and since we are looking in quadrant 2, that angle that gives us a tangent value of -1 is going to be 3 pi over 4. Now remember, tangent's negative in quadrants 2, and then it's also negative in quadrant 4. So the angle in quadrant 4 that gives you a tangent value that is -1 is 7 pi over 4. So it's on that opposite ray. All right, so again, we've got to figure out which theta goes with which r value. So if I rotate to, if I'm rotating to positive 3 pi over 4, I have to go 2 circles out, which is a positive. 2√2 is my r value to get out to that point. So that means 2√2 positive has to go with 3 pi over 4. And then if I was going to be down here all the way at -7 pi over 4, to get to that point, I'm going to have to go negative. So that one would go with -7 pi over 4. So those are my two polar coordinates that would give me the rectangular point at -2, 2, which are two of the things that we did in the last section. All right, so today we are going to look at some equations, and we're going to put those equations from polar form to rectangular form, and then we're going to graph it. Okay, so we've talked about this before. We've got a couple options. We could either square both sides, or we can multiply both sides by r. So when we're changing this one into polar, or from polar to rectangular, the easiest thing to do here is to square both sides. So now I've got r squared equals 16. I can go ahead and take that r squared and substitute in x squared plus y squared equals 16. This equation right here is in rectangular form. Okay, that is the equation of a circle. If you don't remember, it's this is going to be a circle whose center is 0, 0, and whose radius is 4, because if it's r squared, this is r squared, the radius squared, not the polar coordinate squared. And for that reason, we get a circle with a center of 0, 0, because that minus h and minus k are zeros. And then r is 4. All right, so if we wanted to plug in some values to this polar equation, okay, I want to label 2 polar points at least on this graph. So I know it's a circle, I know the radius is 4, but let's talk about the polar coordinates. I know that r always has to be 4. So no matter what theta values we plug in, that r value always has to be 4. So I can plug in something like pi over 6 or pi over 4 or pi over 3. No matter what that r value is, I know that, no matter what that theta value is, I know the r value has to be 4. So if I rotate to pi over 6 and go out 1, 2, 3, 4 points, there is my point. If I rotate to pi over 4 and go out 4, there's my point. If I go out to pi over 6, there's my point. And again, I could keep going around. No matter what angle I pick, the r value is going to be 4. And like we kind of said before, since we put it into rectangular form, I know that's a circle whose radius is 4. So this graph is just going to be the circle whose radius is 4 and the center is at the origin, or 0, 0. Okay, so r equals a number is always just going to be a circle. All right, let's take a look at another one. We got r equals 4 cosine theta. Again, squaring both sides really isn't going to help me because cosine squared isn't something that we can convert to an x or a y. But if I multiply both sides by r, that gives me r squared equals 4r cosine theta. Okay, that allows me to go ahead and switch it into rectangular form. R squared is x squared plus y squared. And then 4r cosine gives me just 4x. All right, we're going to go ahead and complete the square. So I want to move that 4x to the other side. So now it's x squared minus 4x. I'm going to leave a little space to complete the square. Plus y squared equals 0. And again, if I put something on the left side, I'm going to have to put it on the right side. So if I take that negative 4 and I cut it in half and I square it, that's negative 2 squared, or positive 4. I'm going to add 4 to both sides. This right here now is a perfect square. It factors into x minus 2 and x minus 2, or in this case, x minus 2 squared, plus y squared equals 4. All right, so if we are looking to graph this in rectangular coordinates, this is just a circle. The center is going to be, remember, it's the opposite because we set it equal to 0, 2, 0, and my radius is 2. So if I'm graphing this just on a normal xy axis, I go over to 2, and then I'm going to go up 2, down 2, right 2, left 2, and there is my circle. So this is what it would look like in normal xy coordinates, and it should look the same in polar coordinates. So we're going to plug in some values. Okay, so we're going to use our calculator, and we're going to plug those into, r equals 4 cosine theta. So I'm just going to start plugging in some values. So if I plug in a value of pi over 6, I'm going to use my graphing calculator, and I'm just going to type in 4 times cosine of pi over 6, and I get 3.46 if I round. Okay, I don't want the exact value because that's not going to allow me to graph it on here. So if I rotate to pi over 6 and I go out 1, 2, 3, and almost 3.5. All right, if I plug in pi over 4 and I type in 4 times cosine of pi over 4, that gives me about 2.8. So at pi over 4, I go out 1, 2, and a little bit shy of 3, so that's 2.8. If I were to plug in pi over 2, 4 times cosine of pi over 2 is just 0. So at pi over 2, if I rotate to pi over 2, I go out 0. So that actually gives me a point right at 0, 0. All right, if I keep going, I can plug in 2 pi over 3. So if I plug in that to my calculator and do 4 times cosine of 2 pi over 3, and again, make sure we're in radian mode, we get -2. Okay, if I keep going around, if I plug in 0, because I didn't start with 0, if I plug in 0, I get 4 times cosine of 0, which is 4. So again, we can kind of see 1, 2, 3, 4. We can see those points. At 2 pi over 3, we're back -2. We can see that circle forming. We could plug in more points, but I know it is a circle. Okay, the center of that circle is at the point 0 or 2, 0, which is right there in the center. And again, the radius we can kind of see going out 2 to the left, 2 to the right, and technically it goes 2 up and 2 down from there. Those are the ones that are a little bit harder to graph. So having those other points helps us sketch that graph. All right, let's do the same thing for r equals 2 sine theta. Okay, so again, that's very similar to the last one. I don't want to square both sides because sine squared isn't going to help me. But if I multiply both sides by r, I get r squared equals 2r sine theta. Okay, so I know that r squared is just x squared plus y squared because that's one of my formulas. And then r sine theta is y, so that gives me a 2y. Okay, so I want to get everything on one side, so I want to move that 2y over. So I get x squared plus y squared minus 2y. Going to leave a little space to complete the square. I've got a 0 now on the right side, and I'm going to add that number to both sides. So if I take -2, cut it in half and square it, that gives me -1 squared. I'm going to add 1 to both sides. Factor out that y squared minus 2y plus 1, and that gives me x squared plus y minus 1 squared equals +1. Okay, so again, on a typical xy axis, this is a circle with a center of 0, +1 and a radius of 1. So if I were going to graph that, I would go up to 0, 1, and I'm going to go up 1, down 1, right 1, left 1, and there would be my circle. So this circle in polar coordinates should look the same. Okay, so again, we can plug in some values for our to our r theta. So that again, the equation was r equals 2 sine theta. Okay, so I'm just going to plug in pi over 2, pi over 3, pi over 4, and I'm going to plug in 0. So I'm just plugging in some values that will give me some points on there. And you could have plugged in other points as well. So if I type in 2 times sine of pi over 2 into my calculator, that gives me 2. So at pi over 2, I'm up 2 circles, and that's going to be that top of my circle. All right, if I plug in pi over 3, and if I do 2 times sine of pi over 3, that gives me 1.73. So if I rotate to pi over 3, I go out approximately 7. If I plug in pi over 4 into my calculator, let's see real quick. I'm going to use my calculator on here and show you exactly what we're doing. If I plug in pi over 4, I do 2 times sine, oops, make sure I'm in radians, which I'm not on my computer. 2 times sine of pi over 4, hit enter, that gives me 1.41, or approximately 1.4. So I'm going to rotate to pi over 4 and go out 1.4. Okay, if I plug in 0, that gives me 0. So there's 0, 0. I can plug, if I want to get a point over here, I can plug in points, but I know that those values are going to end up being somewhere over there. So we could plug in more points, but we know we've got a circle here centered at the point, what we would consider in rectangular, 0, 1. In this case, it would be pi over 2, 1 would be my center. But we've got that circle on the top half of the polar axis. All right, let's take a look at another one. This time I've got r equals 2 sine theta. Okay, I don't like the way that looks. I don't like the fraction, so I'm going to multiply both sides by sine. So that gives me r sine theta equals 2. If I'm changing this to rectangular, I know that r sine theta is the same as y. So I've got the equation y equals 2. Okay, so again, on an xy axis, I know y equals 2 is just a horizontal line up 2. So our graph should look the same, just on polar coordinates. Okay, so again, if our equation is r equals 2 divided by sine theta, let's plug in some values. I'm going to plug in pi over 6, pi over 3, pi over 2, 0, just to get some values in there. And again, you could pick other values as well. So if I plug in pi over 6, I'm going to type into my calculator 2 divided by sine of pi over 6, and that gives me 4. So when I rotate to pi over 6, I go out 1, 2, 3, 4 circles. All right, if I plug in pi over 3 and type in 2 times sine, 2 divided by sine of pi over 3, that gives me 2.3. So I'm going to rotate to pi over 3, and I'm going to go out 2.3. You can kind of see that horizontal line starting to form. If I go to pi over 2, 2 divided by sine of pi over 2 is 2. So that gives me another point right here. And you can see that horizontal line. However, if I plug in 0, and if I do 2 divided by sine of 0, that actually gives me an error. That value is undefined. So when I plug in 0, there is no value because that makes the denominator equal to 0. So it gives me an undefined value. Okay, again, I could plug in more points, but I know that this is just going to be a horizontal line. I've got enough points to draw that horizontal line. So knowing what the shape's going to look like will definitely help. All right, if I try r equals 4 secant theta, again, this is r equals 4 over cosine theta. So now it kind of looks like that last one. If I multiply both sides by cosine theta, that gives me r cosine theta equal to 4. Well, I know r cosine theta is the same as x, so it's x equals 4. Again, if I'm thinking about the graph of x equals 4 on the regular rectangular plane or rectangular coordinates, I go 1, 2, 3, 4 units over on my x-axis, and it's a vertical line this time. Okay, so again, our graph on polar coordinates should look just like that. So again, in our calculator, we're going to have to type in 4 divided by cosine of theta. Remember, we don't have a secant button, but secant is just the reciprocal of cosine. Okay, so again, I'm just going to go ahead and plug in some values in quadrant 1. I'm going to start with pi over 6, go to pi over 4. We could do pi over 3 if we want. I'm going to plug in, though, pi over 2 and then 0. Okay, so we'll see what those values do for us. So in your calculator, type in 4 divided by cosine of pi over 6, and that gives me 4.6. So when I rotate to pi over 6, I go out 1, 2, 3, 4, and a little bit. All right, so the next one, go to pi over 4. So I do 4 divided by cosine of pi over 4, and that gives me 5.7. So I'm going to go out to after pi over 4, 1, 2, 3, 4, 5. I'm going to go out a little bit shy of what would be our 6th circle. If I plug in pi over 2, that actually gives me undefined because that cosine of pi over 2, we get 0. And if I plug in 0, I get 4. So when I rotate to an angle of 0, I go out 1, 2, 3, 4 circles. And again, you start to see that vertical line forming. We could try more points, but once you know what the shape is going to be, we are good to go. All right, let's take a look at this one. Theta equals 2 pi over 3. All right, so we've got a small problem here with theta. Remember, we don't have a cosine or a sine value, but remember that if I have tangent of theta, I know that that's equal to y over x. So if I'm trying to turn this one into rectangular coordinates, I want to take the tangent of both sides. Oops, tangent of 2 pi over 3. So I'm going to take the tangent of both sides. That allows me here to plug in for tangent y over x. And then I know from my unit circle, tangent of 2 pi over 3, if I look at 2 pi over 3 up here, that's the ordered pair negative 1/2 root 3 over 2. Tangent, remember, is y over x, so I take my y value of 3 root 2, divide by -1/2, which means I've got to take that denominator and I've got to flip and multiply by -2/1. So tangent of 2 pi over 3 is just -√3. All right, if I want to go ahead and solve this for y and put it into rectangular form, I'm just going to multiply both sides by x, so those x's go away. So I get y equals -√3x. Okay, this looks a little bit strange, but hopefully you realize that that's actually the equation of a line. Y equals mx plus b. Technically, our y-intercept is 0. It has a slope of -√3. So that graph is just going to be a line with a y-intercept of 0, 0, and a slope of -√3. So again, if I graph it on an xy axis, my y-intercept's at 0, 0. My slope tells me to go down √3, right? It's -√3/1. So I go down 1.73 and then over 1. So it's going to be a line that goes in that direction. Okay, so the interesting thing that if we plug in points for this, my equation is theta equals 2 pi over 3. So just like when our equation was was r equals 4, all of the r values have to be 4. Here, all of my thetas always have to be 2 pi over 3. Okay, it doesn't matter what the r value is. So I can start with an r value of 1, go to an r value of 2, I can do an r value of 0, I can do an r value of -5 if I want. I can plug in any values for r, but the theta value always has to be 2 pi over 3. So again, we know approximately what this graph should look like on an xy axis, but let's graph it on polar. So if I rotate to the angle 2 pi over 3 and go out 1, that gives me a point right there. If I rotate to 2 pi over 3 and go out 2, again, I could go out 3, 4, 5, it doesn't matter. If I'm at 0, there's 0. And if I'm in the negative direction, -1, -2, -3, -4, -5. So you can kind of see that straight line. It is just a straight line at the line, or that goes on the ray 2 pi over 3. So it goes up into the positives and then also down into the negatives. So anytime we have the graph of theta equals something, it is going to be a straight line on that angle. That is all I've got for today.